So let's go ahead and consider kind of reading this here. So it says, consider the differential equation dy dx equals negative 2x over y. Okay. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. So go ahead, take a few minutes and do that, would you please? Okay. Sketch the slope field for this differential equation. Again, use some shortcuts here. Okay. Don't use some shortcuts, but I mean, like, see if you can like figure out some patterns so you don't have to like figure out every single individual slope. Look for some shortcuts.
No. I don't. Sorry.
Oh, you want something better? Yeah, take one. I was just gonna put lunch line.
Okay. So, volunteers here. What are some ways we can kind of do this easily? Ryan?
Well, for all the values where x equals 0,
Mm-hmm.
it's going to be 0.
So that's the y-axis, right? So all these slopes on the y-axis,
Are going to be 0.
horizontal slopes.
Then, trying to figure it out, that you just figure out the 2 in one quadrant, they all kind of mirror each other.
Okay. So at 1, 1, we'll have a slope of -2, yeah?
Yeah.
Okay. Something like that. And then at 1, 2,
You have a slope of -1.
-1. Okay, something like that.
So then you can mirror that over the...
Okay, so you're saying it's symmetric here, okay? So yeah, -1, 1, x-coordinate -1 becomes -2, but it's -2, so it's +2 over 1. So yep, slope of +2. And that's going to be a slope of +1, I guess, because it looks like -1 for the x-coordinate, so it would be +2 on the top, +2 on the bottom, so a +1 slope. Like so.
Yeah.
Okay? And so it's going to be the same thing for... Oops, sorry, that's supposed to be steeper. Like that, like that, like that, and like that. Okay, so something like that. Okay? There's our slope field. Okay? All right, cool. Letter B then, it says, letter B, let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equals -1. Okay? Write an equation for the line tangent to the graph of f at 1, -1. So again, notice here it mentions the particular solution to the differential equation, but it does not necessarily tell us to find it. Okay? It doesn't say necessarily to find it. In fact, letter C, it tells us to find that. So letter B here, it just says, let this be the particular solution to the differential equation with the initial condition f of 1 equals -1. Write an equation for the line tangent to the graph of f at 1, -1, and use it to approximate f of 1.1. Okay, so how do we write the equation of a tangent line? What do we need? Okay, we use the derivative to find the what of the tangent line? The slope. Okay, what is the derivative of our function? -2x over y. Yeah, it's the derivative right there. There's the derivative. Okay, so for letter B here, all right, we have to evaluate the derivative. Okay, remember that little vertical line there? And you can put like the coordinate there. We're going to evaluate the derivative at what point?
1, -1.
Yeah, 1, -1. Notice here we need both the x and the y coordinate, right? Because those are in our derivative there. And so it's going to equal just -2 times 1 over -1. Okay, so that means our slope is 2, right? So what else do we need to write the equation of a line, though, of a tangent line?
Point.
A point. Do we have a point?
Yep.
Yeah, it's 1, -1. Write an equation for the line tangent to the graph of f at 1, -1. So our equation then is, y, good. Y plus 1 is what it's going to end up being, because it's y minus -1 equals m times x minus our x coordinate there of 1. Oh, but our m, sorry, is 2, so. Okay, so there's the equation for our tangent line. But what else are we supposed to do? Use it to approximate f of 1.1. So where should that 1.1 go in? And for the x, yep. So it's y plus 1 equals 2 times 1.1 minus 1. Okay. This one, by the way, let's see here. This one is, ooh, it doesn't say. I believe it's non-calculator, though. Pretty sure it's non-calculator. But we can do this, right? No problem. What's 1.1 minus 1?
0.1.
0.1. And what's 2 times 0.1? 0.2. Okay? And then we're going to subtract 1 from both sides, so we get y equals 0.2 minus 1, which is -0.8.
Like it. We figured it. Like that.
Okay? So there's the approximation using that tangent line. Yes?
You didn't have -0.8.
If you just put -0.8, you should probably be okay with that. Maybe 0.8. Just make that decimal point real obvious.
Does it want a coordinate point or no?
Well, it just says use it to approximate f of 1.1. So, yeah, I think we're good there. There's the value.
Nice.
All right, letter C. Find the particular solution. Are we all okay with that word, particular solution? Like what it means, right? When you find the particular solution, y equals f of x, to a differential equation, what does that mean we have to do?
You have to...
Yeah, we want to separate the variables and take the integral, okay? That's the step, okay? If you're given a derivative and you want to find the solution to this differential equation, then you integrate, okay? And we're going to use that initial condition. So, let's see here. I'm going to pick somebody.
Kind of picking like a year.
A year.
Probably you could just pick some.
Austin, actually your number just came up, so there it is. All right, so
Yeah.
Austin, first, no.
It's gonna blow up.
No. My bulb's dying, I think, though,
Does this
sadly.
mean we don't have to do calculus anymore?
That's exactly what it means.
Okay?
Yeah, go right on the board.
Go right on the board.
Go right on the board.
All right, hang on. I'm gonna let it cool off like that.
You wanna turn it off?
Okay. No, it's running, so it'll like emergency cooling it right now.
Should let it cool it.
Well, it's just the fan's blowing real hard. That's all. 'Cause it's hot. It got hot.
Liquid nitrogen cool it.
Okay. In the meantime, though. Okay. While we're waiting for the projector to not be so angry anymore.
One time I was doing that,
Okay. So go ahead, Austin. What should be our first step here?
cross multiply.
Cross multiply. Yeah, we want to get the dx over, okay? In fact, I'm going to do that as an initial first step here. Okay, so we multiply both sides by dx. Okay, this is something you should always do, first step, no matter what, okay? Don't try and, like, if it looks fun, always multiply that dx over. So you're always getting your x and dx on the right side, your y's and dy's on the other side, okay? So now, what should we do to both sides?
Multiply y.
Right?
Yeah.
Okay. So, y dy equals negative 2x dx.
Correct. And then integrate.
Okay? Right, and at this point, we're going to integrate because we have our variables separated. And now we're going to switch it off to Caleb. Okay, so Caleb, at this point, what should we do?
You got it.
We did, so what's the integral of y?
So 1/2 y squared negative x squared.
Good, okay, now, since Caleb took care of both integrations simultaneously, he didn't need to write plus c on both sides. 1 plus c is fine. If you do write plus c's on both sides, that's okay too. That's okay too. But since he did both simultaneously, then he just wrote 1 plus c here. If you do one first, and then you hold off to do the other one, you need to write the plus c as soon as you integrate here. Okay, so this is fine what he did. All right. Now, let's see here. You'll notice that it says to find the particular solution. Ooh, that is still okay. Never mind. It said to find the particular solution here, y equals f of x. So when it says find the particular solution, y equals f of x, that means we want to solve for y in terms of a function of x. So have we solved for y as in terms of a function of x here?
No.
Yeah, no, not yet. So, Caleb, can you take us through that, solving for y here?
Yep. So you multiply both sides by 2, which would give you negative 2x squared plus c.
Yep, good. The c kind of absorbs that times 2. Okay, and then what?
Well, I would just get c first now and then.
Oh, you want to go ahead and get c first? Okay, that's fine. So what Caleb has chosen to solve for c first here before we like kind of get the y by itself. So go ahead, Caleb. Then how we solve for c here?
So you substitute negative 1 for y and 1 for x.
Okay, so we know there's a point, right? We're trying to find the particular solution at the coordinates 1, negative 1. And so we're going to plug 1 in for x, negative 1 in for y, and solve. So we get 1 equals negative 2 plus c, so c is 3. All right, and so now we've got y squared equals negative 2x squared plus 3.
And then just take the square root.
Square root both sides, okay? Y equals plus or minus the square root of negative 2x squared plus 3, right? We do the plus or minus because we're in an equation setting. Now,
There's an issue here.
what, you guys remember from yesterday, we ran into a problem like we did one just like this, where we had the plus or minus, and you remember we got rid of one of those signs.
Get rid of the plus.
Okay? How did we know to get rid of one of those signs?
Didn't it say that it has to be, that y has to be positive?
Okay?
Or negative or something?
Yeah. So what's the one point? What's the one point? So again, this is a description for our function. What's the one point that our problem told us has to be on our curve? What's the point, the coordinate that has to be on our curve? 1, -1, right? Okay. This cannot happen both plus and minus. One of these we have to get rid of.
The plus.
Why the plus? Yeah, our y coordinate's going to be negative, so we have to get rid of the plus. It's got to be only negative. Square root, -2x squared plus 3. And let's just check it right now, right? 1, plug it in. 1 squared is 1, times -2 is -2, plus 3 is 1. Square root of 1 is 1, but it's -1. It works. Okay? So do you see that there? Get rid of the plus or minus 1, only -1. Or negative, only negative. Okay? Only negative. Okay. Does that make sense?
No.
Makes sense now.
Okay, it makes more sense now. We get help, we see it again. Yes?
At a point.
Good. Hooray.
Da.
Okay. I want to point out one other thing. Oh, if you feel, if you got up to like this point, and you're like, I get this, and you got to here, and you're like, I don't get this, that's really okay. Because let's look at the scoring guidelines for this now that we've gone through it all.
I don't know.
Oh, I will make it work.
Did you try turning it on and off?
Yep, you take the plug out, and you put the plug back in, and the red light goes away. It's magic.
Once you turn on the...
And it goes, and then it starts to smoke and pop.
The bulb just explodes.
Mr. Witt's projector is like Robert's car.
Yeah, except it doesn't have 495,000 miles on it.
I'm gonna
I'm just giving it a little bit of fresh air.
The guy's like, does that really say 490,000 miles?
Okay. So let's look then at the answer key for this.
What's wrong with it?
Okay.
There's something wrong with this game.
So there's our slope field. All right, looks good. Okay. Notice again where the points come in. You get 1 point for the zero slopes, 1 point for the non-zero slopes. So again, there tends to be, it looks like 2 points available in most of these slope fields, okay? And they kind of like separate the different slopes. Sometimes it'll be like 1 point for positive slopes, 1 point for negative slopes. In this case, it's 1 point for zero slopes, 1 point for non-zero slopes. If you miss one, you don't get the point.
How explicit are they about like the slopes being like? I mean, like you can see the difference in mine, like that
Right.
one's like non-steep, the other one's like
That's about it. That's about it, what you just said, the steepness of it.
just so they can see that there's a difference.
And obviously, like, positives and negatives, right? So, like, positive slope versus the negative slope, you should definitely have those straight. But as far as, like, they're not going to you're not going to add more points in and say, oh, this is actually a 1/3 slope, not a 1/2 slope. You know what I mean? But it's a good, valid question.
So if you're like, if your slopes, if you think they're not going to be clear enough, could you like put like an arrow pointing to one and be like, this
is a slope of...
is
I don't know. I wouldn't worry about that. I really wouldn't worry about that. All right. Question, yeah.
We use this point to graph the undefined slopes.
I would suggest against doing that.
Okay.
For the sole reason of be very hesitant to ever give more information that's asked for, because if you end up making a mistake in that information, they can sometimes, you can lose points that way. Even though there's not a scoreable point for it, if you say something incorrect, if it's additional information. So in other words, it asks you to sketch a slope field at the 12 points indicated. So just stick to those 12 points. Stick to those 12 points. Okay, let's keep looking here though. Letter B, all right? 1 point for the equation of the tangent line, 1 point for the approximation. So again, even if you maybe make a mistake with the arithmetic, you still get a point for coming up with the equation for the tangent line. It's a point there. And then look, letter C, 5 points. Okay? If you can nail letter C, which again, this is stuff we've just been doing this entire unit, if you can get C, you're almost on your way to that magic number 6 points out of the 9 to be on your way to a 5, okay? Again, 6 out of 9 points on a free response question, that is on pace for a 5. If you can maintain that for all the free response questions, 6 out of 9 points, that is on your pace for a 5, okay? Because that's about 66%, which is roughly what a 5 would be. Okay, it's borderline 5, but it's still a 5, okay? That's so many points for something so simple. We just, like, so just normal kind of calculus problems. So again, 1 point for separating the variables correctly. 1 point for the antiderivatives, okay? So here, this one, you only get 1 point for antiderivatives. You have to do both correctly. They're both kind of simple, so that kind of makes sense. 1 point for putting in a C. Again, so easy. Just put a plus C after you integrate. That's a point, okay? It's so simple. 1 point for using the initial condition. So that means, again, plugging in the initial condition is a point. Not correctly solving for C. Notice there's no, like, correct value for C here. It's just using the initial condition. That's a point. And then solving it for Y, that's another point, okay? So if you didn't get that, you know, if you messed up here with the, if you put plus or minus and you left it that way, that would be just 1 point that you missed there, okay? Again, notice other notes there too. So anyway, Brandon?
For the slope field, I don't think that they would do it, at least I hope they wouldn't, but if you ever get something in indeterminate form, what would you suggest doing?
The slope you mean? Again, you wouldn't. They wouldn't. Yeah, they wouldn't do that to you because you can't graph something in indeterminate form. Yeah, you would have to. I don't even know that. You'd have to graph it. Like you're saying, like 0 over 0, right?
0, 0 on this one would be both.
Right.
Yeah.
Like 0 over 0. 0 over 0 is not even undefined. It's like sometimes 0 over 0 can be simplified to actually be a number. Sometimes it can be simplified to not, have a value at all, though, too. 0 over 0 is like, well, we don't really know what that is. Yeah. Okay. So let's look at another one here then, while my projector is still alive. Okay. So let's go on to number 2. Okay. Number 2, you're actually going to see this again in the future when we start reviewing for the AP test. We're kind of like reviewing now in a sense. This was on an AP, let's see here, which test was this on? This was on the 2012 test, so not that long ago. Pretty recent, right? Okay. People were thinking the world was going to end, and they, but here we are, so.
Why didn't it?
I don't know.
That's really hard.
Probably, or maybe there's like, screw it, just here's a question about baby birds. Have fun. Have fun.
Can I write little notes on my AP test?
You can, yes, but I would again be hesitant.
No, little notes like.
Why did Grandma pass away today?
Right, exactly. Yeah, right. Yeah, why did Grandma have to pass away today or something like that? No, I would not, because you're going to waste time just answering.
Why did Fido come off the bridge?
Right, exactly. Great. No,
Call
don't
me
do that.
555 whatever,
Just
whatever.
know the calculus and you'll be fine. All right. So, yeah, right, here's my kick. Yeah, okay, anyway, here we go. So, the rate at which a baby bird gains weight is proportional. We know that, right? That means that K, right, to the difference between its adult weight and its current weight. Okay, so let me read that again. The rate at which a baby bird gains weight is proportional to the difference in this case meaning subtraction, right? Okay, difference. So you're going to subtract the adult weight and its current weight. At time t equals 0, when the bird is first weighed, so time t equals 0, bird is first weighed, its weight is 20 grams. So that's probably, we're thinking, that's when the baby bird is born, right? At time t equals 0, the baby bird was born, and so it's 20 grams. Okay, it's like a little... Anyway, if B of t is the weight of the bird in grams at time t days after it's weighed, then dB dt, okay, so the rate of change of the weight of the bird with respect to time equals 1/5 100 minus b. Okay, let y equals b of t be the solution to the differential equation above with initial condition b of 0 equals 20. So again, we're just defining this function b of t to be the solution to this differential equation, and it has initial condition b of 0 equals 20. Now, we shouldn't be surprised that we have this point because how do we know this is going to be true without them writing it? At time t equals 0, when the bird is first weighed, its weight is 20 grams. So it's like, duh, at time t equals 0, the bird's weight should be 20 grams there. It's just kind of like, repeating information. Also, if you look here, the rate at which a baby bird gains weight, dB dt, is proportional. There's your k. The k is already solved for you here. It's 1/5, okay, to the difference between its adult weight, 100, minus b, its current weight. You see that? It's written out for us right there. There's that differential equation that was in that sentence. Okay, so, letter A. is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your answer. All right. So we're trying to not look at what the bird's weight. Oh, sorry. We know the bird's weight. It's 40 grams, 70 grams. Okay. We want to know at what point is it gaining weight faster, when it weighs 40 grams or when it weighs 70 grams. How can we determine this? So ideas. I heard a few things, but I just want to say, what do you say, Tyler? Plug in each to what? Plug 40 into DBDT?
Well, 40 for B.
40 into B.
For that.
Right, how do you know that we can put 40 into B there?
Because it says B is the weight of the bird.
B is the weight of the bird. So if you plug 40 in for B, that's a place where you can put it, because 40 is grams, it's the weight of the bird. So okay, let's go ahead and do that. So I'm gonna kind of run out of space here. I'll do it on a separate sheet of paper. Okay, separate sheet of paper. Here we go. So 2A, we'll do dB dt equals 1/5 times 100 minus 40. And then we'll also, so that's evaluated at B equals 40. And then we'll do dB dt evaluated at B equals 70. And that's 1/5 times 100 minus 70. Okay? Just get another little cool breath of fresh air. There you go, little guy. Okay. Keep it up. Okay, so anyway, 100 minus 40 is 60. 1/5 of 60, 12, right? 100 minus 70 is 30. 1/5 of 30 is 6. Okay, so is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams?
40.
Okay, 40. So 40 is correct, and let's go to Nate. Can you tell me, why do you think that's correct? Why is the bird getting weight faster at 40 grams?
I was not paying attention, sorry.
Okay, that's fine. We'll go to someone else. We'll come back to you.
Better than just a minute, then the bullcrap, I went through it.
What's that?
Better than just a minute, then bullcrap through it.
That's right, exactly. Okay, Trinity, how about you? Why is it at 40 that the bird's weight is getting? Why is 40 indicating to us that the bird is gaining weight faster at 40 grams than it is at 70 grams weight? Yeah, 12. Yeah, the dBdt is larger value. Exactly right. Yeah. 12 is greater than 6. Okay. All right. 12 is greater than 6. So the bird is gaining weight faster when it weighs. Sorry? You can say that, but again, we want to talk about, it asks faster, so we should probably use the word fast. We should probably use the vocabulary they're using. So the bird is gaining weight faster when it weighs 40 grams.
Probably have like a Big Mac or something that
Okay.
day.
Now, this is not part of the question, but it could be, what are the units?
That'll be grams per day.
Grams per day, right? So think about it this way. dB, that's the change in weight. What's weight weighed in? Weight is in grams. And T, rate of change of time, is in days. So this could be grams per day. Okay, so just a little throwing that out there. That's not part of the question, but something we should be able to answer. We can answer here. All right, next. Letter B. Find d squared b over dt squared in terms of b. Use d squared b over dt squared to explain why the graph of b cannot resemble the following graph. All right, so Anna, what's this thing? What is this thing? The second derivative. How can we find the second derivative of something? Or what can we do here to find the second derivative that we want to find? Take the derivative of dB dt. You got it. Okay, so we're going to do, if you want to write this way, you can. You don't have to write this way, I guess. But we're going to do the derivative with respect to t of dB dt. And so that's going to be the derivative with respect to t of this thing here, 1/5 times 100 minus B. Okay. So this is going to give us d squared b dt squared. Okay. So let's see. I'm going to simplify this right-hand side here first. So let's distribute that 1/5. 1/5 times 100 is 20 minus 1/5 b. Okay. And what's the derivative of 20 with respect to time? 0, so it goes away. What's the derivative of negative 1/5 b with respect to time? Negative 1/5. Not dt, db dt. Okay? This is like taking the derivative of y. Right? This because we're taking the derivative with respect to t, but it's a b, so we have to write it as db dt. Okay? So really then we just have negative 1/5 db dt. Okay? Have we answered the question that was being asked? Or have we found d squared b dt squared in terms of b, Anna? No. So what do we still have to do here? Well, we have no b here. It's db dt. Nope, not yet. We need to. So again, we've got right now. This is what we have. We have d squared b over dt squared is equal to negative 1/5 db dt. I want the second derivative, right? Find the second derivative, but I need to rewrite this thing in terms of b. Right now it's in terms of db dt. But what does db dt equal, Anna? Yeah, plug this in. Exactly right. Plug this in. So it's negative 1/5 times 1/5 times 100 minus b. Okay. So you can see it's very much like that implicit differentiation. Remember when we were doing implicit differentiation, we took that second derivative. You oftentimes had to plug in that first derivative because, it showed up again in the second derivative. Okay. Oof. Now that's kind of messy, right? So let's try and simplify this a little bit. So it becomes negative 1/25 times 100 minus b. Okay, which is then negative 4 plus 1/25 b. Okay, you could have stopped right here. I mean, this is a fine answer there, but I want to simplify it a little bit because we still have some more work to do. It says use that second derivative to explain why the graph of b. So again, this is the graph of b cannot resemble the following graph. So let's see. Oh, sorry, I'm like not able to show everything. There we go. Okay. So again, use the second derivative to explain why the graph of b cannot resemble the following graph. So how can we link the second derivative to the graph of b? How can we use those? What is the second derivative?
Concavity.
Yeah, concavity, right? So this second derivative is talking about the concavity of b. So we need to look at the concavity of b here and see some sort of discrepancy with our calculated second derivative right here. So any ideas there on that? How might we do that? Connor, what do you say?
So we could do like the weight at like, it looks like 30.
Okay, so you're saying at like the weight at roughly, so like just a little bit above, right here, okay? And so what type of concavity do you see indicated there when the weight's 30?
Like concave up.
Concave up. But if we were to plug 30 in, 30 times, 30 over 25 is like 1 point something. 1 point something plus a negative 4.
No good.
Yeah, no good, no good. Okay, no good. It'll be a negative value. Okay, so here it would indicate we should have our be concave up, but here it indicates concave down. Okay, and in fact, okay, for the entire interval from 20 to 100, okay, from 20 to 100, what should the concavity be here? Yeah, it's going to be concave down. It's only at 100. So if we look here, so what I mean is, I guess, let's take a look at this. So if I set this thing equal to 0, okay, and find our possible points of inflection, we get b equals 100, basically. So we have a possible point of inflection at b. So that means if I put in, make our number line here at 100, okay, and I've got b, prime, if you want to think of it that way. Okay, if we pick a number to the left of 100, so like, we can even, like Connor said, 30, we're going to get negative values. If I pick a number to the right of 100, what values are we going to get for our second derivative? So you could pick something easy. You could pick like 125, right? 125 is to the right of 100. 125 divided by 25 is 5, plus negative 4 is 1, so it's going to be positive. Okay? So according to our second derivative here, the b should be concave down for what interval? 0 to 100, right? But if you look at the graph here, from a weight of from 20 to 100, we're sometimes concave up, and then sometimes concave down, okay? And so that's why this graph can't be accurate, okay? So the graph is incorrect because it is concave down for an interval between between 20 and 100. Okay? But the second derivative, or I'll just put, but d squared b dt squared is negative for the entire interval. It's negative for the entire interval from 20 grams to 100 grams. Indicating b should be concave down. From 20 to 100, something like that. Okay. So again, it's kind of restating the question in a sense. Okay. The graph is incorrect, right? It's telling us the graph is incorrect. We just have to describe why it's incorrect. Okay, so something like that. And of course, there's maybe more efficient ways to write it, but there that is. Okay. All right, and last thing here, letters. So questions on that? We're all okay with that? What?
For this part, is it not enough just talking about points of inflection?
You could use points of inflection, yes. You could. You can say that in this graph, it's indicating that we're changing from concave up to concave down, indicating a point of inflection between the two, and then stating that, well, according to mine, there should not be a point of inflection. Yep, absolutely. There's a couple ways to go about doing it there. Again, because all you have to do is just show that there's an error. I went one way, that's another way to go too. Now, another thing I want to point out here, letter B. Let's say you came across letter B, okay, you're in the wild, you're on your own, you're doing this pre-response question, you look at letter B and you're like, I have no idea. That's okay. Skip it and move on to letter C, because letter C has nothing to do with letter B, okay? So please don't feel like these all follow in some sort of progression and you have to get all of them right in order to get some points. No, skip around. So letter C, for example, is completely, independent of letter B. So let's go ahead and do letter C right here. It says, use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. All right, so let's go to Connor. So Connor, how can we find y equals b of t here? What should we do? Okay. So we have to separate our variables though first, right?
Yeah,
So how should I go about doing that here? The dt I need to multiply over, right?
Yeah.
I need to multiply that over. So I'm going to rewrite that. Let's get that part out of the way, right? That's something you guys should all know. First thing I'm going to do, multiply that bottom dx or dt, whatever you got, multiply it over. Okay, now.
Divide by 1/5 parentheses 1 b.
And you can go two options here. You could keep the 1/5 and just divide over the 100 minus b, or you can divide over the whole quantity. It's up to you.
Let's just do the 100.
I like that too, yeah. Let's divide over just the 100 minus b. So we have 1 over 100 minus b, db, equals 1/5 dt. Okay? Good. All right, let's go to Emma. At this point, Emma, what should we do? Integrate. Okay. Just like American history, we segregated first, and then we integrated. Okay.
Okay.
Guys, it's history.
This is non-calculated.
That's not how we should have done it in history, though. This is how we do it for calculus, so we need to do it. Okay, so yes,
This is non-calculator.
this is non-calculator. So Emma, let's do this side here. What's the integral of 1/5 dt? Yeah, 1/5. Nope, not x. T. Yeah, there you go. 1/5 t plus c. Good. Okay, good. And then Emma, 1 over 100 minus b. Is that just natural log of 100 minus b? Yeah, not quite, is it? No. What do we need to use here? Yeah. Use substitution. Let u equal 100 minus b. Okay, believe it or not, yes, we do need to do that. Because du is going to be negative db. You see that? If we had just done natural log, you might have missed that negative sign that we needed. Okay, so it's going to be negative du equals db. So I can rewrite this integral then as what? Yeah, so negative du, so I'll put the negative out front and make it that way. That works. Okay, and what's the integral of 1 over u, Emma? Yeah, natural log of the absolute value of u plus the c. Okay, so you see there are some tricks inside. All right, and we get negative natural log of the absolute value of 100 minus b plus c equals 1/5 t plus c. Okay.
How would you, looking at that, how would you know that you can't use the natural log? I feel like I would look at that and just use the natural log.
I mean, okay, so one kind of hint here, right, is that the only integral that we know that gives us natural log is the integral of 1 over u, okay? So typically we'll see maybe 1 over x, and that's fine. But anytime you see anything other than x, 1 over x,
What if it's 2 times?
you want to consider using a u substitution there. Okay, well, it's 1 over 2x, you can pull the 1/2 out and make it 1 over x.
You would have just gotten du is dv, that's when you can use the ln, right? Or, if you would have used the substitution and then you figured out that du just equals dv.
Yes. Correct, yeah. And so, I mean, even, Emma, if you have something like 1 over x plus 2, okay, if you have 1 over x plus 2, you could actually get away with just doing natural log of the absolute value of x plus 2. But it's not wrong to let u equal x plus 2 and just go about it that way. So I guess maybe when in doubt, just go ahead and use a u substitution, you know? You might, kick yourself because you had to spend a few extra seconds doing it, but it's better to, get it right, I'd say, in the long run. So anyway, all right, so there's that. Now what? I guess I can get rid of the C's. I'll just put the 1 C over there. But now what do we do? Okay, so again, I'll rewrite it here. We got negative natural log of the absolute value of 100 minus b equals 1/5 t plus c. Were you going to say something, Emma? Yeah, we got to figure out what our c is. Okay, what can I plug in? Yep, exactly right. So 20 will go in for what variable? At b, exactly right. That's the weight. So negative natural log of the absolute value of 100 minus 20, and then what goes in for t? 0. So it's just going to be c equals that. C equals negative natural log of 80. Okay, so now what? We have to rewrite negative natural log of the absolute value of 100 minus b equals 1/5 t minus the natural log of 80. Okay, so we plugged it in for c. Are we done?
No, I need to
Yeah, if you look here again, folks, the directions kind of give it away, and I'll kind of fold my paper back here so we can kind of keep both things on at once. Find y equals b of t. So it means we have to find b as a function of t. So we have not solved for b yet. So again, if you stopped here, you'd get almost full credit. There's 1 point you're going to miss out on, though, if you don't solve for b here, because you got the c value, right, but we have to solve for b as well. So, pick someone else, Emma. You've done good enough there. We'll get someone else to take over from here. All right, so Nate, at this point, what do you say?
I am so...
All right, we'll go on to someone else. Tyler, what do you say?
I know what I'm doing spring break.
Yeah, that's right. Looking at this stuff. All right, well, I'm going to give you guys one to try on your own for spring break. So anyway.
Evil sides.
E, okay, so let's first take care of this negative. Right, so let's multiply both sides by -1.
Negative one side. Oh, you know, something for us to do on next Monday.
Okay, and then, yeah, E both sides. So that's going to give us 100 minus B on the left-hand side here. And it's going to be E to the -1/5 t plus natural log of 80. So again, it's 100 minus B, so... Okay, so you get negative B equals E to the -1/5 t plus the natural log of 80 minus 100. We have to multiply both sides by -1. And so it becomes B equals E to the -1/5 t plus natural log of 80 negative E, sorry, plus 100. Like that. That was a bit of a marathon right there. You look at that and got it wrong. But again, that's because we're not familiar with doing these kind of problems. This is actually a very typical kind of answer you get for these kind of problems. So it's not atypical, this kind of answer. Now, there's one other little thing here, right? We could, this natural log of 80, what can we do with that? You can bring it out front and make it negative 80 e to the 1/5 t plus 100. But this is fine to leave it like that, too. Okay, that is our final answer there. That's it. Okay. So again, let's look at the answers. Let's kind of break it down here. Look at our points. How many points we got? All right. Can I move this? Is anyone still writing this? We're good? All right, so back to our points. So letter A. Okay, let's see here. So there it is, 12 and 6. Because dBdt is greater than dBdt at 70, the bird is gaining weight faster when it weighs 40 grams. So there it is. 2 points right there. Boom, boom. Okay? Letter B. Okay? This one was only 2 points, and so if you skip this one, that's okay. Okay? If you look here, let's see, the argument they gave, so they found the second derivative, and they saw that, okay, so B, just because of this, B was going to be concave down for this entire interval, because for any values there between 20 and 100, this was going to be positive, times a negative would end up being negative. So a portion of the given graph is concave up. So there's kind of the thing there. All right, then letter C, look, there's those 5 points. Easy peasy 5 points. I mean, not easy peasy, but I mean, you can get a lot of points from this, right? Separation of variables, that's a pretty easy point. The antiderivative there, maybe a tricky thing with the 100 minus B, right? Constant integration, one for just putting a plus C, initial condition, and then solving for B. Okay, and you get that as your final answer. Right? So there it is. All right. For the remainder of class, what I'd like you guys to work on is the landfill problem on the back. Numero 4, okay?
Is this our time for break?
You know what time it is? It's time for
Siesta.
Siesta. You can take a siesta.